All right, so I just wrapped up the first section of the preamp here. Basically, the way it works is I have these 22 volt power supplies going through the circuit here, which creates 15 volts positive, negative, and ground going into the preamp board. And I also have this Bluetooth receiver auxiliary in here. So what we're doing is we have here 100,000 ohm back to ground through these capacitors. This prevents, basically these are decoupling capacitors. They then go into the preamplifier. With these resistors here, what I'm essentially using the preamp for is to buffer that signal. So about 300 millivolts comes in and about 3 volts comes out. So it's a 10x gain on this side. These capacitors here, these small ones, are essentially between the ground and the positive and negative into the preamp. So again, 15 volts negative, 15 volts positive, with the capacitors to provide immediate smoothing and power for the op amp if it needs it. The output then, we have two channels here, right? We have left and right. Those outputs will then go to these potentiometers. So we have treble, mid, bass potentiometers here, and each one of them have the different networks for being able to modify the signal based on, different capacitor values and different resistor values. The idea is that this op amp is going to go through all of these, which they'll be used for tone control, and eventually they will lead to another op amp, which I'll talk about later once I get there. Essentially, that op amp will do the final amplification from 3 volts to something much higher. The other thing I want to note is that I am using here an inverting op amp, or the way I have it hooked up is inverting. So we have essentially a 108-degree phase shift on this one, and we'll do it again on the final one. So at the end of the day, first op amp to sort of buffer, provide high voltage for the circuitry, and then the final op amp, which will lead into the actual main amplifier section. So this is for the stereo channels. Again, I've decided to do a 2.1, so these will be the stereo controls. This will be a volume pot, so the output of this will go through here. Then I'll have another board completely different for the subwoofer. The subwoofer is going to use completely different circuitry because I want to have a very aggressive low pass filter. So we're going to limit everything to only 200 hertz and below, and that one will also have op amps, but the difference there is it will have to sum left and right channels. So I'll go through that circuitry, how I do the summing with one op amp, then do the fall off, and then do a final amplification with the second op amp there. Essentially, here's the explanation of what I just showed. We have left and right channels coming in from the Bluetooth board with 100K back into ground. We then go through the capacitors, the 1U capacitors, to prevent coupling. So it's a decoupling capacitor. We then go through this initial op amp. Again, I'm using one physical op amp because it has two different circuits. So this is actually one physical device here. We have a 10K resistor with 100K feedback. So this has essentially a 10-to-1 amplification ratio. So 300 millivolts comes in, 3 volts comes out. We then have the 1K resistor between the op amp output, and then this is the actual tone control boards. As I mentioned, bass, mid, and treble all have different resistor sizes and different capacitor sizes. You can look up exactly how this works. It's pretty straightforward, but the potentiometer allows us to do essentially a sweep from one output of the circuit into the other. And that will go into the final op amp, which again, it's inverting the way we have it hooked up. And the difference here is that we have the output of the op amp fed into the output of this circuit, the input into here. And again, I could share a little bit more details if anybody's interested, but at the end of the day, we're going to have a pretty good solid signal to work with here outside of this op amp. And this is the rest of the amplifier that I'll be building. I'll be taking the input voltage signal up to about 22 volts or so. This ensures that the emitter drivers here are going to have 22 volts to work with. So not just gain from a amplification perspective, so not just an amp gain, but a voltage gain as well is what we're working with. So we'll be using 4 transistors per channel. Each channel I've got right around 50 or so watts maximum for the main satellite speakers. I'll be using double the transistors for the base, as well as working with 2 rather than 4 ohms. So that will be a little over 100 watts. Each speaker is rated at 30 watts, so the amplifier can put out twice what I need here, so I'll definitely not be pushing it to the max. And each subwoofer can take about 30 watts too, so again, I'll be running the amplifier pretty cool. Here's the new box being printed. This is the bottom half for 2 of those 3-inch subwoofers. And so far, this is sort of what I'm trying to build. We already have the little satellites. This is the subwoofer box I'm printing. I already have this shield. And finally, I'll be building the actual amplifier case, and I've already shown the little voltmeters. Here it is. Very, very cute. And that'll be it. So the design is basically done. I'm just putting everything together.